Well, I was asked about the inside of the transmitter. You can see the large high voltage filter capacitor, bleeder resistors for that on top of it. Right there with that tube looking thing on it, that's not a tube, that's a time delay relay, gives you about 3 minutes. You probably put that in there to give it time for the mercury vapor rectifiers to warm up. That transformer you see there and the bleeder resistor in front of it, that's the high voltage power supply, 2866 mercury vapor rectifiers on that. And it also has a relay on there, so if you get over current on it, on the high voltage line, it'll kick the transmitter out of line, kind of protecting that circuit there. This is the modulator. You got the front tube there. That is a 6SJ7. That's the microphone amp. The tall one, metal cased one behind it is a 6N7. It's a dual triode. They have the dual triodes paralleled. And back there are 6L6 GCs. And that, two main modulator tubes are Taylor TZ40s. And that's the modulation transformer in there. That's the back of it. You got the high voltage connections there. Grid current metering. And on the back, that's the interstage transformer. You mount it off the back there. And that's the modulator. We'll move up. Back up a bit here. That is the modulator power supply. You got your low voltage section, 2 mercury vapor rectifiers, the smaller one, and a couple more 866As for the high voltage portion of it. That's it all uses oil-filled caps. I had to replace a dual section 4 microfarad and 2 microfarad oil-filled cap. It started leaking. You could see where someone tried to use silicone to seal it up. Well, you can't do that on those caps. And I use an individual 4 microfarad and an individual 2 microfarad mounted under there and replace that. This is the exciter section. The actual exciter is behind there. You can see the antenna connections. And that small BNC is a little sniffer I put in there so I could drive a frequency counter in a tune position without powering the amplifier. You can tune up the exciter, and that I can also see what frequency I'm on. You see a little fan up there I added. This VFO was quite drifty. There was vent holes at the top there. I kind of cut it out and put that little fan there. It's a 110 volt AC fan, and that greatly improved the VFO stability. It takes a good 45 minutes for this thing to warm up and settle down. And that is the power supply right there for the exciter. And the way you had everything wired, my line voltage is about 125 here. All these transformers were 115, 117. And if I powered it right from that, the filaments for all the tubes would be excessively high. And the way it was wired, it was easy to implement. I put a variac I had laying around. That way I can control the voltage just going to the heaters. The modulator high tension power supply and the plate supply is still derived right from the 127. I didn't want to run that through that, and it works perfectly fine. And you can see down on the main power supply, I put a terminal strip so I could connect the variac to that, and that way that's controlling all the heater transformers throughout the whole transmitter. So everything is getting the proper voltage so you have proper output. Right there is the final PA unit. And up top you can see the meters. Over there, that little transformer, that powers the lights. And he also has a light bulb in there. You open the door, light bulb comes off, on, and also disables the transmitter from transmitting. And it has the antenna connections. The white one is to the receiver. The center one there is out to the antenna, and that's a 1/4 inch phone plug there. That's the muting for the receiver. And it's a Dow key relay, and there's another key relay over there that when you transmit, when you're not transmitting, it passes the signal through the Dow key to the receiver, and when you're transmitting, that relay there will short the input to the receiver. or right now I have a little 50 ohm termination on that, so when it goes in the transmit, the receiver sees a 50 ohm termination on the antenna terminals. And up on the that's the meters up in there. That's the inside of the cabinet. This was built in a bud cabinet. That was real popular then. I see a lot of transmitters people post are built in the same cabinet. Well, that's the inside view. We'll go through one here one more time. I'm using a little handheld light. My lighting sucks down here. It's a nice area, but lighting doesn't do good for the camera. It's a stand-core modulation transformer. Let's see if I can read the number on it. It's a Type S22 Special Series. I'm sorry, it's a United Transformer Corporation modulation transformer. There's a closer look at the TZ40s, Taylor TZ40s. Let's see if we can get a little closer in on the power supply. That's a Thordson transformer. And of course, the big oil-filled main filter cap. That's a Westinghouse. And inside this compartment here, there's an AC fan that draws air through the PA unit. Probably also keeps a little negative air pressure in the whole cabinet that it sucks out the heat that's built up. And you can see the bottom of the door. Top of the door has venting, along with the bottom of each side of the cabinet. So you're pulling a lot of air through this thing, trying to keep it cool. What it does is it brings in air on the side of the PA unit on this side, goes through the PA unit, and out the exhaust on the side there. A little bit of thought put into cooling, and it works well. The interior of the cabinet stays, well, gets a little warm but not hot, I'd say. That's it. Pretty neat. Somebody built this in 1964. And the only thing that bothered me about it is they didn't use different color wires on anything. Everything uses the same wire. You must have had a big spool of wire and use the same color for everything. So it was kind of a chore tracing everything out and figure out everything gets hooked up. Because when I got this, everything was set in place, but none of the wiring was hooked up, so I kind of had to decipher and kind of follow through where things connected. I double checked even though the plug connections kind of lined up, but you know, just like you got two red wires for grid current. You don't know which one's going to the negative side or positive side of the meter. Of course, heater voltage, you know, for the metering, it's AC, it doesn't matter. Now there's the bias switch there. Inside the amplifier, he's got rectifier tubes, negative 45 volt bias, and I think the other was about 90 or 100, I don't remember. That little cap I put on there, that's the high tension line. It was bare open, I just put that on there just because you really can't power it up with the cabinet open unless you bypass the interlock switch that's up there. But pretty neat. And that PA unit is a Millen design. I think a diagram I found was from 1946, and everything's almost spot on with that. Well, that's it. Now you got to see the inside.